Hello, I'm Pam Hoffman, Everyday Spacer.
Jeff Miller, 2049 Outfitters. Yeah, that's the one.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific Time, 12 midnight Eastern Time, and 12 noon on Saturday in Hong Kong. We're broadcasting live from Thousand Oaks, California. Thank you so much for joining us. Last week we got a really cool comment. We did the Collecting Meteorites show, and DeSilco said that cool video. Thank you for helping more people get familiar with this fascinating area of both scientific study and a wonderful hobby for space nerds. As this has recently been my main area of interest, I've managed to put together quite an extensive collection of meteoric material. I hope you don't mind a few small corrections or additions. And I think that's a great way to address the video. We really like to hear your comments. We really gain knowledge and experience from this very thing. And so I urge you to go and look at the comments from Disvilco because you might enjoy them too.
Okay, back to this. There, I just wanted to show us.
Okay.
Okay, tonight's topic is listener questions.
It's listener questions night.
Yep. And we'll be back in 8.3 seconds. Okay, in February, David Reneke suggested answering viewer questions. We tried it in mid-February, and it was such a success that we're doing it again tonight as a recurring feature. This week, you are the focus of the show. We have some questions to kick us off and give you time to tune in. We'll watch closely for your questions and your answers as they come in. So, first question to just kick it off. What kinds of stars are there? Or what types of stars are there? And you have that somewhere?
Yeah, you know what? I have to share screen though, so let me do that.
Good job.
And if you have questions, definitely get those lined up for us.
I think you have to do whole screen unless it's in a Word file.
There, it's there, but I'm on the wrong place. So this is kind of the original Hertzsprung-Russell diagram, or HR diagram. And I think it's very nice because you see luminosity, dimmest to brightest, and temperature, coolest to hottest. Weirdly, they have red as coolest.
Well, yeah, if you think about it, and I'm going to be getting into this a little bit next week, is that, hi, Cliff.
Hi, Cliff. Welcome. Thanks for joining us.
If you think about it, when you heat up metal, it goes from black to red.
That's true.
And then starts getting, and the term white hot, basically, hottest.
Okay.
I think the metal melts before it gets to blue, but it gets white hot.
I'll buy that. All right. So, and this is the one I'm very used to. We've got some categories here: super giants, red giants, main sequence. That's along this whole big long line here. Red dwarfs are in there. White dwarfs are below. And then I found this one, which is much more graphic. And it actually kind of shows them, because I know Arcturus is a very large star, and yet there are some that are even bigger. And there are some names in here if you want to take a look at these. And I just put, I think I just put HR diagram when I did my search for these. They're categorized O, B, A, F, and G, K, and M. And like Jeff was saying, this is actually going to be the topic,
or part of the topic.
Part of the topic for next week's show. But we'll get into that a little bit later on in more detail. So we definitely want to get your questions. Like we said, we have a few that can kind of get us started. If you don't have any questions for us, it's going to be a short show.
Okay.
I kind of like this one.
Yeah. Oh, here, Dan
Hey, Dan, welcome. Thanks for joining us. You got a question for us? Yay!
If we need to build quartz domes on Mars, where would the silicon most likely come from? Well, it might be deficient in quartz, but it has silicon in plenty. I mean, almost all rock has silicon in it.
Okay.
I mean, it's one of the most common elements in the rocky planets. Now, it's not pure silicon, and it wouldn't be as easy as, say, a silicate sand or something like that, but you could definitely do it. You throw enough energy at it, and you can make it. And then it's just a case of cooling it slowly enough to actually make a good crystal.
And we may find something interesting and unique to Mars that would serve the very same purpose or even better. I mean, this is the kind of thing we don't know until we get there. We find the materials that are being collected right now, get returned to Earth, and we can play with them, that kind of thing.
And I think a dome is going to be a luxury for a long time for Mars. I think that, if you want security, you're going to go underground first.
Yeah, I think there's lava tubes on Mars, right?
Yeah, and there's digging, but lava tubes are probably best. There was a sinkhole that was just really deep and wide underneath the sinkhole.
On Mars?
Yeah, on Mars.
Oh, yeah. I didn't know about that. Okay.
Yeah. And I think that was a volcanic event at some point.
Okay.
In the long time ago. But quite frankly, underground is going to be better for radiation shielding.
Yep.
Until you fix, if you go on the terraform route, you have to figure out how to give Mars a magnetic field for any kind of long-term terraforming.
Yeah. And there's another question. Will that type of a dome even protect you enough from radiation? From
some.
Okay.
I think mostly it's just strong enough to not take a hit from from a small rock.
Harder to remember. Well, I guess you could let's not go there.
Oh yeah, I came up with one too. Yeah, let's not go there. I do know that astronomers do have a sentence that they made out of that. I don't remember. Yeah, I don't remember what it is. But
I hadn't heard that.
Yeah.
Okay.
I read, and it might not be something that they do now. I read it in a 1950s science fiction thing, and it was bandied about as if it was common.
Yeah.
Or at least common in astronomy classes. So.
Okay. All right.
I don't know.
Oh, good. Yeah. More questions? Yay.
Yeah. Yeah. All sand is mostly silicon. Yeah. It all depends on what else is in there with it that makes it harder or easier to get this silicon out of.
Cool. Thanks, Cliff. So, like we said, we just have kind of a few here to get us started. Why do some stars appear to twinkle? I get this question a lot, actually, from regular folks. Oh, it's twinkling. Well, that's basically from atmosphere. And what I like to talk about is, how there's a difference between what's, between the Earth and straight up from you and straight across the horizon. There's a lot more atmosphere in that tangential version than straight up perpendicular to the ground.
Yeah.
So really it's an atmospheric thing. Once we get out of the atmosphere, they don't really do that. Even things like on the James Webb Space Telescope, they had those very pointed star things. That's an artifact of the telescope. It's not the star itself that's doing that. Oh, I think we got more.
Yeah. Oh, yeah. It's called scintillation. Yeah.
Scintillation. Isn't that a great word?
Yep. And, we were looking at the ISS, was it last night or the night before? And it was really low on the horizon. And at first I thought it was an airplane because ISS doesn't usually blink, but it was blinking. And then I realized that it was going through the branches of a tree that had lost its leaves.
Oh, right. Yes.
So I guess it does blink if it's behind a tree.
Well, yeah, many things can make a difference.
Yeah. Stars twinkle, planets don't. Good to remember.
Ah, okay.
And oh yeah, oh be a fine. Yeah. Yep. Yeah. There you go. Did you know that,
Excellent.
Dan, or did you just Google it right now? But yeah, that's what I remember. Now that you wrote it, that's what I read.
Yeah, and I think that is pretty old. So definitely, what are your questions? And we'll do our best to answer them tonight. If we have to look them up, of course, we got the crowd here too. We can rely upon to help us with the answers. If we do have to look them up, we'll answer them at the
Yep.
beginning of next show. I had to Google it.
Good on you for being honest about
Yep.
that.
Excellent.
Besides,
And you know, that's a great way to deal with things. You know,
yep.
your brain does a really good job of thinking and innovating, and it's irrational. So there's lots of things that can happen that, oh, you see things and all of a sudden they're a new thing when you put them together. But yeah, you've got something like a search engine. Absolutely make use of it. That's a very engineering thing.
And besides, you know, you can either use your brain for remembering a whole bunch of minor details, or use your brain for thinking up how to find them.
Yes.
And that's much more universally useful.
Yeah, I think so too.
Yeah. And
what you got?
What will your next book be about?
So are you asking me or Jeff?
I think you, because
or someone
I don't
crowd.
have one yet. I don't have one yet.
I am writing 2 sequels to my very first book. It's the Your Amazing Itty Bitty Explore Space Now book. So there'll be, the first one was 15 simple ways to get involved. The second one will be 15 additional ways. And the third one will be 15 advanced ways. I'm actually going to number them. First book 1 to 15, the second book 16 to 30, and the third book 31 to 45. So there'll be clues in there that there are other books involved. A little marketing thing going on there. Do we have more? Awesome.
David,
yay.
Question: why does time stand still at the event horizon?
Ooh.
Actually, it does not at the event horizon.
It doesn't. Okay.
It's just much slower at the event horizon. It's once you get in there, basically, it never actually stands still, but it gets so close to, as you approach the black hole, basically time slows more and more. So it never, theoretically, in this, because you can never tell what happens inside a black hole, theoretically, you never actually reach the black hole and time never actually stops, just because it gets so slow as you're approaching it that you never actually get there. That's again, that's all theoretical. That's taking the laws of physics and relativity and taking them all the way out to there be dragons.
And maybe the James Webb Space Telescope will help us with even more answers for
but
things like that kind of thing. I don't know. That'll be
yeah
for that one.
Yeah.
And thank you, Dave, for asking.
Yeah.
Really
and one of the things that I liked about Interstellar is that they had stuff going much slower near the black hole.
And Interstellar, for those who don't know about it, is a movie. When did it come out? Do you know?
A while.
It's been a while. Yeah. Gosh.
But
speaking of time.
Yeah, it's what 2 events arrest time. Oh Lordy, David, tell us. I kind of dread hearing the answer to that.
Should be good.
Yeah,
that's fine. Well, but here's the thing. I mean, you know, who knows? We're gonna find out more and more as time goes on. It's a really great time to be here to learn all these interesting discoveries. I mean, they've seen not one, but 2 black holes now. They've taken pictures. Well, basically, that's a compilation of imagery and data and stuff. But we got 2 pictures.
Oh, Michael. Greetings from Hong Kong. Hey,
Hi, Michael. Welcome. Glad you could be here. We are taking questions from the audience. Strong gravitational fields can retard time.
Yes, because they cause acceleration. That's what causes time to slow, is acceleration.
Okay.
And when you're in orbit around something, you're constantly accelerating because the gravitational field is pulling you. That's why and its relativity is actually part of the GPS system, because the satellites are actually moving slightly slower than we are here because of sorry, faster, because they're not moving as fast. So yes, they're moving. They're going. Time is actually slower for us than that is for the satellites, I believe, because they're
I forget,
because
I know
we're
we've
going
seen
around the
something
Earth.
about that.
We're going faster than they are. You know,
Yes,
I don't know, one way or the other,
because we're closer to the center of the Earth. Oh,
right.
we got somebody's got something to say.
Yeah.
Hey, Anthony.
Yeah.
Welcome.
Of
course, the other is light speed. Einstein and said moving clock runs slow.
Yep.
Oh, super smart.
Yeah.
Theoretical stuff.
Yeah. Basically, as you approach the speed of light, you get slower and slower until you get to the speed of light, and hey, you know.
I guess my engineering thinking cap is, well, how can I use that? I don't necessarily care about that, but how can I use it to my advantage?
The trouble is that to approach the speed of light requires all the energy in the universe.
We'll see.
So, that's theoretically, of course, because your mass gets infinite.
Right.
As you approach, because not only does time slow down, but your mass increases.
Yeah.
And your length decreases. Oddly enough, one of the thought experiments that we did in college was, how fast do you have to move a 5-meter rocket so that it fits in a 10-meter barn? Because it will get shorter.
Is that
as
the other
it goes.
way around? A 10-meter rocket into a 5-meter barn?
Or yeah.
Okay.
So, 15 foot to 10 foot. That's how I learned it. I was trying to translate 3-meter barn, but yeah. So it's just basically, and you can actually calculate that. And I did. I don't remember the answer because that was decades ago.
Yeah.
Oops. You're gone.
Hey,
Daniel, if China laser destructs the Starlink network into metallic powder, would it be a Kessler syndrome, denied access to space? And how could we fix it?
Holy mackerel.
Okay. A lot to unpack there.
That's my first answer. I don't know.
They'd have to take a lot of shots.
Can China do that?
Possibly.
Okay.
But it'd take a lot of shots to do that. And I don't know that necessarily the stuff would blow up from the laser. I think the laser would heat it enough to make it non-functional. But and here's the other thing that they could use: a rail gun. That would get the effect that you want.
Okay.
I don't think that there's enough mass in the Starlinks, and they're close enough to the atmosphere. But I think most of it would come out. It might cause some problems for the short term, but I think, since China wants to be in space, that'd be kind of a Pyrrhic victory for them, because they wouldn't be able to get in either. Maybe the Russians would, because they build their stuff like tanks. I mean, have you seen one of their rockets? It's got bolts on it. Not friction welds, not fancy stuff. It's got bolts.
Yep.
Yeah.
Built a launch from Baikonur. Yeah. One event says stops. Time is the day you die. Really? Okay.
But not for everyone else. But of course, time and space are relative.
Yep.
But so yeah.
And if that's true, we don't know. We don't know that's true. I mean, have we passed over now? Is this the other side of that life? Other side of a life? We don't know. Yeah. I think I saw another one.
Oh. The Kessler would make billions of crap up there in that scenario. Yeah. Yeah. Basically,
You're talking about space debris.
Yeah, space debris. Yeah. Basically, because the Kessler syndrome is space debris makes more space debris. And if fragments go whizzing around and they hit other things that make more fragments and that sort of thing.
Okay.
And basically,
but stuff does come down with the solar winds. They can bring some. I think it's especially the lightweight things, right?
Right, and especially the things in very low orbit, which is what Starlink is. But and the solar winds and also the solar heating of the atmosphere is that when we're on closer approach to the sun, our atmosphere envelope actually expands, and things that are nearby can get, can hit the drag of the atmosphere more during that. So
yeah, because I know the space station is constantly having to boost itself back up.
yeah, and that's
you look at the pattern and it'll kind of go down and then it'll pop right back up.
Yeah, which is why since the thrusters are on the Russian part of it, and the Russians said that they're not going to cooperate, we could lose ISS because.
Yeah. I hope that's not true. Did we get another one? It looked like maybe we did.
But I suspect that there's a plan B for getting that boosted by docking something to it. Okay, what do Miss Pamela and Jeffrey think of the level of astronomy education taught in your schools?
I'm not sure that there is any that's taught in the schools.
Yeah, I don't think
nowadays things are
college, or basically if you have a high school physics teacher that is interested in the subject, they usually talk about it a little bit. But I know that I didn't get much in physics in high school. I got a little bit.
No, I didn't really either.
Yeah, I know that because I was an AP physics, but
and explain that for people in other countries.
Advanced placement physics.
Advanced placement.
But
thank you.
The other physics class I know, because I looked at their textbook, was a lot of space stuff.
Oh.
And it was wrong.
Oh, yeah.
That was like.
Yeah, that's hard. Yeah, they're doing weird things in our schools right now, Dave. And when you talk about schools, let's see, because we have different. Of course, there's primary, and then classes after that. Then there's college, high school, and college. So we kind of have 4 levels. If you want to clarify,
yeah,
and we don't really know, because when you when you go through school, stuff, and then when you have a kid, you kind of know stuff again. But at this point, my daughter's almost 40, and we haven't really been involved with. Well, I guess Jake, you know more about with Jake's school, but Jake is Jeff's nephew, and he's in a school that's for super brilliant people. He tests higher than Mensa. Yeah, apparently. Something called, what is it, Phoenix or something?
Yeah, there's some little subgroup of Mensa that oh look, I've got a plaque. I get to be in this group. Okay.
They're special.
Yeah. Which is about how he feels about it.
Yeah, I think there's a lot of deficiencies in the schools in the United States, not just in sciences. They've gotten rid of a lot of really important arts and different, kinds of classes.
Arts and a lot of math and sciences are not as invested in.
Well, and they've done weird things with the math too. It's very strange here.
Yeah.
It's more about gender than.
Yeah, I mean.
Why, I don't know.
Apparently, 2 + 2 = 4 is oppressive to some people.
Okay.
Yeah. Okay.
Yeah. Hard to say.
Yes, Starlinks are very small. Yeah.
That's what I thought. Does anybody have an idea of their dimensions or anything? Are they like CubeSats that are like, very?
I think pretty much
10 centimeters by 10 centimeters.
I think they're bigger than that, but not by a lot.
I don't really know.
Because they're, they pump out dozens of them when they pop them out.
Yeah.
Hey, Anthony. Good evening. As you are taking questions, what do you think the most significant discoveries we'll learn from JWST are?
I think we're not going to know.
Yeah, I think
until we find out. I mean, that to me, that's a valid answer, because I just don't know that we're going to know until we learn it.
Well, yeah, I'm pretty sure that at least once with the JWST, the scientists are going to be looking at something going, huh.
Oh, yeah.
And that's where we learn something new,
Yeah, I think a lot of times it's wow.
Yeah.
Or, whoa, what is that? Or
or just, when a scientist goes, huh, we learned something new. We broke current knowledge, and we're learning something new.
Yeah.
And so we invented space. Yeah, no, not necessarily. We,
No, I
we,
think the Russians did actually.
well, no, the Germans did. We and
No,
the Russians just
no, the Russians.
we and the Russians just stole it from
No,
Germany
no,
after
I'm
we
talking. I'm talking
beat 'em.
about even longer ago than that. The what's the book? Everything happens in the mind first, and so if you're writing about it, you can call it science fiction for now.
Well, there was
but
Jules Verne.
no, before
Wells.
this, he was Russian. He was Russian.
Well, there was a Brit that had the brick moon.
Mm,
Um,
I'm thinking a long time ago. I mean, really long time ago.
there,
Maybe somebody out there will remember. And
there was a Frenchman.
I could look it up.
There was a Frenchman who had geese
Yeah.
flying.
No, I'm talking about before that. I mean, like
A
true rocketry, working out all the physics, and I know it's a Russian guy. Ah.
Yeah.
I'm on the show, so I'm not looking it up.
Yeah. That's gonna bug you all night.
Yeah,
It's
maybe.
Gonna be amusing. David,
Oh,
when I was at the Winter Star Party in the Florida Keys in 2008, they had a NASA trained astronomy teacher. Ooh, neat.
very
Who
cool.
also taught in primary schools, middle schools.
Yeah, and I think by the in Florida there, where a lot of that industry is, where they launch from, that kind of thing, you may find higher concentrations of that kind of training.
Yeah, basically because it's in the mindset of everyone.
Yeah, if a lot of the parents are engineers, they're going to want their young people to learn that kind of stuff.
Yeah.
More than, say, someone in Kansas in the middle of nowhere.
Mhm.
So,
Yep.
see more? Yay!
Yep. Daniel, my 7th grade science teacher, Mr. Graham, was a huge astronomy buff
Nice.
and had a star party for my first live view of Saturn's rings and Jupiter's moons.
Ooh, cool.
I was overview affected for life.
Yeah.
Yep.
Very good.
Yeah. You know,
Love hearing that.
My first live view of Saturn, I was already an adult, and it was at a science fiction convention.
Oh, cool.
I'm thinking it was an Agamemnon.
Yeah?
We had someone set up an 8 or 10 inch out there, and city lights viewing was horrible. But
by the Burbank Airport.
Yeah, by the Burbank Airport. Yeah. So we had all of that LA, LA area next to an airport.
North LA, yeah.
Yeah. So, but we were able to see Saturn, and we're able to see the rings.
Oh yeah, there's a lot you can do right from your backyard, even if you have a lot of lights.
And I'm surprised that that's my first view, because my mom dragged me everywhere. My mom's view was we should experience everything. So
that was my idea too. I took my daughter everywhere that I could.
Yeah, but that was the first time I actually saw them.
Very cool. Current version.
The current version of each Starlink satellite.
Oh wow, that's bigger than I thought.
Daniel's Googling again. 537 pounds. So
roughly the size of a table. Okay, that's much bigger than I had this kind of visual image of something being more along the lines of a big CubeSat.
No. Well.
So much bigger.
Yeah.
Okay. Excellent. Thank you.
So there would be a bit of mass there, but for if you were to blow it up, but it still might, you need an awful lot of them to do something other than make it just slightly more dangerous. About the size of a suitcase.
A suitcase, okay.
We might be thinking difference between folded and unfolded. I don't know.
Oh, I don't know either. Do they actually deploy some kind of solar panels?
Yeah, they must. They've got to get their
otherwise they have nukes, right?
Yeah, and
they'd have nukes, but nobody has
no
nukes.
one's going to be launching nukes into low Earth orbit.
No,
they have to go through all kinds of rigmarole to put it on something that's leaving, leaving our system completely.
Right. Okay, so if we want to keep this going, we got a few more questions here. If you have more questions over there, please let us know. Was that a new one from Cliff?
No, that's what I showed.
Okay, that was. All right, so the suitcase comment.
Yeah.
Okay.
So what's the difference between astronomy and astrology?
Astronomy, astrology, whatever. You said that with a group of amateur astronomers and you'll be remembered. David Levy probably remembers that. But I mean, think about it. The first astronomers made their money doing astrology.
Well, astronomy came from astrologers because they were trying to make their predictions better, so they had to learn the motions of the
I thought it was
stars.
the other way around.
No, because they were
Okay.
astrologers.
All right.
And they learned the motions of the planets to more predict. And, that's where astronomy came from, is
Okay.
they we got science out of that, eventually. Just like chemistry came from alchemy.
Okay.
And the fact that people were just mixing up stuff anyway, not calling it chemistry. Yeah.
Got it.
But so yeah,
And to me, the difference is that you are out looking at things, and you think about in terms of astronomy, what is a star made of? What what are the planets made of? How far are they? Kind of measurement things. Not like with astrology, it's more about how does that affect me in my life. And I guess the saying is the stars do not compel, they impel. I'm not sure. I have no expertise in astrology. I know a little bit about astronomy because there's so much to it, and a lot of what I do is very, very practical. I think if of the two of us, the person that kind of holds on to the more theoretical stuff would be Jeff. I'm pretty much go out there. Let's look at things. Can I fix it? How does It's more engineering-ish, technician-ish,
yeah.
that kind of thing.
Had a high school teacher, not one of mine, but I read about this in the U.S. that asked for on a Friday asked for all of the students' birthdays, and he said that he was going to do their astrology reading for them over the weekends. On Monday,
I think I heard about this.
he brought it out, handed it out to each person with their name on it, had them open it up and look at it, and asked them, okay, how well does this fit you? And everyone said it fit them very, very well. He then had the students hand it to the person on their left because it was the exact same thing.
They're all the same.
Yeah.
I think I had a thought, but let's go to the comments because we want to hear from you.
How do you get some telescope time on the JWST?
I think it's actually possible.
Yeah. How long is the wait list, and who would decide?
I don't know how long the wait list is, who decides that kind of thing, but I think it's possible. And I think it's just fill out a form. And of course, the earlier the better, of course. And also, the more interesting the project, I think, is going to determine getting that time.
Yeah.
On JWST.
Yeah, I don't know exactly how they're doing the JWST, but it's probably very similar to how they do the Hubble. And
I thought it was more open than the Hubble. I thought the Hubble, there were more restrictions based on.
They had a committee that decided stuff.
I don't know exactly, but my feeling was that the James Webb Space Telescope was going to have a more broad, availability to, regular people. Actually, that might be a great show. And if you want to hear about that, let's put it on our list.
Mm-hmm.
We got a whole huge list now.
Yeah. Yeah, and Cliff, I saw Saturn for the first time through my new 8-inch Meade, and then my wife in her first comment was money well spent.
Yay.
Yeah.
Very good. So it stopped raining there. Good.
Well, I think he means a while ago, but
oh, I see.
I was hoping that was Saturn.
I was hoping that was like news. Stopped raining, no flooding.
Yeah.
Let us know.
Yeah.
We're thinking about you.
First time I had a really good view of Saturn was actually through one of our scopes. Yeah.
Oh, okay.
Yeah, where it could actually see the separation of the rings instead of just being lobes off of this.
Yeah, it might even have been the 10-inch from the club. I borrowed a
No, actually it was the spotter.
Oh, the spotting scope. Yeah, that spotting scope is quite amazing.
Yeah, the optics on it are great.
Yeah, they're very, very good. And I think it's computers now that we can, and we did a whole show on that. So take a look. The thing about astrology, and I read this somewhere, was that it gives us a chance to brag about ourselves without feeling self-conscious. Like, oh, I'm an Aquarius and I'm, analytical and this and that and the other thing. We don't have to
I'm a Leo. I win.
Yeah, see what I'm saying? But what I've done with it too is made it a gateway drug to help people to find their. My question is to kind of more general populations is, so what's your sign? And then the follow up is when they tell me what it is. Have you seen whatever it is? Have you seen Leo in the night sky, for example? So hopefully, I'm kind of bringing them into the wonder of, involving themselves with astronomy and the things that you can do with it. I mean, it's so broad. It's so broad and so deep. You could go deep, 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 deep into one particular thing, or you can hit the surface of many, 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 many things. But yeah, I've created a 2-page PDF for a number of the astrological signs, the Western astrological signs, and I'm like, tell me what your sign is, and can we see it in the night sky? Oh nope, you'll have to come back later. And it gets a laugh. So there's a lot of good ways to kind of it's like supermoon. It's not really a thing per se, but it is, because now it is, and everybody wants to see a supermoon, right? Well, I can't tell the difference between a supermoon and the normal moon. It's like 4%, just because it's a little closer to the Earth in its orbit. It's like perihelion. Yeah, it's. And if it's a full moon, and it's so sort of the intersection of a full moon and the closest. So that's what the supermoon is. If you didn't know. And astronomers are like, but
on the names
I don't care.
Of the moons.
Whatever gets anybody, wanting to know more, I think is a good thing.
Yeah.
But that's just my idea about, those two, astronomy and astrology. I think I saw one.
Nope, that was.
You sure? I thought I saw it move.
Oh, hang on.
Yeah, I thought so.
Oh.
Did we get okay?
Daniel, how much money can you save by making your own telescope?
Oh, well,
if you don't count the labor, I think you can spend a lot more money.
Well, I'll give you an example. I ground a mirror for a telescope, and the class. This was a while ago. It was $50. It was like September through June time frame. For once a week, we'd go out. We'd do the work and stuff. So, and I got it done. I had to get it done because Norm Oberly, our instructor, he was retiring. So, it didn't take a real long time. It was $50. That included all the parts, all the materials, all the grits, that kind of thing. And I have yet to build a telescope around it. It would be pretty easy to get a lot of components in some, here's a piece from here, from this person there. So you could, kind of Frankenstein something together for not a lot of money. It's going to be ingenuity and time and your labor, yes. But it probably wouldn't be too much in terms of actual cash layout. Of course, if you want to do that, great, because you're going to learn something. And I did. I learned a real lot from grinding a mirror. If you want to have a telescope to use, call up the VCAS, Daniel. Become a member and borrow a telescope from them. So it just depends on what you want to do. Do you want to have a telescope to look through, to use, to observe?
Or do you want a project?
If you want a project, you want to learn what it takes to get a mirror to a specific shape, all those different things, the different grits it takes. Yeah, it depends on what you want to do. I thought I saw something again.
And Cliff. Yeah. Yes, it was years ago.
Oh, I see. For the picture.
Better. Yeah.
Okay. Got it. All right. Do we want to hit some of these Earth questions? How old is the Earth? How big is the Earth? What is the Earth made of? How much does the Earth weigh? And we know the answers to these questions, don't we? How fast does the Earth rotate? How fast does the Earth move around the sun?
Yeah, we could Google those, but how old is the Earth? I think current is like
4 billion,
4.5. Yeah, 4.5 billion is like the current thought, but you keep finding older rocks, and so that keeps pushing the age back.
Unless you're on a certain path and it's only 6,000 years old, so something like that.
Yeah, just 4 billion year old rocks were made for it. How big is the Earth? I don't know. It's
And
I know somewhere. It's in my brain somewhere. It's not
yeah.
accessible.
But what's interesting to me though is that like the ancient Greeks figured things out, like
Oh yeah.
orbits and circumference. All these different things. They knew
Well,
that the Earth was a sphere.
simple geometry.
Yeah, it's pretty much math and well, and I think was it Cliff who had a picture? Toronto, at the shoreline, and then Toronto 20 miles out. Sorry, flat earthers.
Yeah.
I mean, now for the time now, for people to think that the Earth is flat, well, okay, but it's a bit mind-boggling to me when the ancient Greeks could figure that stuff out with, I mean, shadows. They had a stick in the ground and they had a shadow, and it was different heights at different places, and
yeah, well, different lengths. Yeah,
different lengths. Yeah, the shadow was at different lengths. I mean, this is how they figured out that the Earth was a sphere.
Yeah, and the calculation that they did all way back then was really darn close.
Oh yeah.
To what it is now. I mean.
Oh yeah.
Within a fairly decent margin of error. I mean.
Yeah.
Fairly small margin of error. So that was
right.
that was pretty good math there.
And so we're kind of throwing these out there to stimulate you. If you want to learn more, we can go do some digging and do a whole show about X factor of what we're talking about. If you have more questions, great. I see we're at 41 minutes. Why don't we?
Oh, we are? Wow.
Yeah, it's been 41 minutes. We're so glad you're here to participate with us.
Yeah.
It's much more fun.
Earth weighs more than most rocky planets of its size.
Oh, it does?
Yes, because the planetoid that hit us to basically splash off the rock for the moon had a core.
Yes.
That joined our core.
Okay.
So unless early planet growth is that chaotic in all other systems, Earth is probably denser than most.
Oh, interesting.
And plus we blew off some of our lighter rocks, and that made the moon.
Yep, that's right. Okay. So it'd probably sink in water. Is that what you're saying?
No.
Well, I think Jupiter would float. Isn't that one of the things about Yeah,
if you took
will it float in water is kind of
if you took its average density, if you took the density of its inner parts, then no.
Oh, okay, got it. I thought I saw another one come up.
Oh, yeah.
Do you want to check? Thank you.
Oh, video of John Dobson making a scope is an eye-opener, as it can take a lot of work to make a scope.
Yeah, I spent months going week after week. My friend Dawn, she and I went. She was making her second mirror, and it was a 20-inch. So she had like an 8-inch, and she was making a 20-inch. I don't know if she's built that telescope around it. She probably has, because there's a big community there. Of course, you can't do astronomy very well in northern Ohio, so of course that's what you got to do. Out here, where it's beautiful and spectacular, and oh my God, you can see the stars. Not as much, but that's how that goes.
Yeah, well, since they can't look at stuff in the sky, they make the toys.
Oh, okay. Got it. But we spent months, week after week, and each class was it had to have been a couple of hours. I mean, we drove quite a ways, and we spent, and you basically turn and then go around and around and around. Yeah, what is it? What is it? Yeah, that was a good thing. Yeah, Toronto.
Yeah.
Yes, right. That was very good. It very definitely exemplifies what the heck is going on when it comes to the Earth as a sphere. All right, so if you have more questions, go ahead and add them in. I'm going to go ahead with the stellar events for this week, and we're talking June 3rd through June 10th. It's going to be kind of quiet, except in the morning, and I'll talk about that at the end. June 7th is the first quarter moon. June 8th is the weekly space hangout. They're talking about SPARC, SPARC. It goes sparking nuclear fusion with Amelia Caballero. Oh, I do have that one. Let me go set that up, and if you don't mind sharing screen right about now, that'd be awesome.
There we go.
So there's that information. I think this is going to be a great show. I think if you want to do that, absolutely tune into that. Let's see. They are in the last few weeks of their season. I will be appearing on June 29th, and I think that'll be the last show until September.
Yep. Yeah,
What do we got?
Cliff says Earth has a very large magnetic metal core.
Yeah, and
Yeah.
it's still molten. That's why we have the magnetic field and
yeah, and so Earth might have a stronger magnetic field than most too, because we've got the additional core,
yeah.
chunked into there. So who knows? I mean, Earth might be an outlier, or it might, or it might be typical.
I think when we find out about planets external to the solar system, it just keeps being mind-boggling. I mean, the things that they're seeing. We just watched something about that, didn't we?
Yeah,
it was terrific. So and again, we'll be back on June 10th. It's our Friday night show. Just going to talk about stars. Find us Friday nights at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel. Now, of special note, something I think you should watch for, especially if you're an early bird. And I actually just took it from this the almanac, the Old Farmer's Almanac, from the 16th until month's end. All of the planets form a line like string of pearls. Moreover, they appear in their true order from the sun. From the lower left to the upper right, some 45 minutes before sunrise, look for Mercury, Venus, Mars, Jupiter, and Saturn. The crescent moon visits each. Look for the moon below Saturn on the 18th, Jupiter on the 21st, to the right of Mars on the 22nd, above Venus on the 26th, and above Mercury on the 27th. So that's a really exciting sort of thing to me.
So since the moon's auguring in, when does it hit the sun?
It will be near the sun. That's what the new moon's about. But that's coming. I'll probably reiterate that in the next week or two. But yeah, I just wanted to alert you to the fact that they're going to be this nice lineup of planets in the morning before sunrise.
Yeah.
Over to you.
And nominations are closed. We will announce the winners of the Everyday Spacer of the Year 2021 award in October during World Space Week. The broad categories are space exploration, science, and astronomy. And our committee will help us figure out the winners.
Stay tuned. We have some ongoing activities and events. Space Prize. Link there for me? Yeah, thanks. This is going to be launching this month, so watch for Space Prize Global. It's a worldwide contest to promote the advancement of women in STEAM, science, technology, engineering, arts, and math, specifically in aerospace. This is open to 15 to 18-year-old women worldwide. Contest features a combination of written, video, and creative submissions. 2 grand prize winners will each receive a $250,000 prize of private astronaut experiences. And I guess they're going to be going on this space perspective flight, which sounds really cool. And we checked. Artemis is still accepting your name to go on the test flight of the Space Launch System rocket in the Orion spacecraft around the moon. If you haven't gotten your name on, check it out. It's like you get 1.3 million miles or something, and you get a boarding pass image. It's pretty cool. Yeah. Mostly for fun, but it's pretty cool.
Yeah, it's like naming a star.
Yeah,
that goes on no official registry anywhere.
Yeah, but they'll actually put your name on a thumb drive and add it to the launcher, and it'll go.
Yep.
If you care about that sort of thing.
So, if you or someone you know has done something interesting involving space exploration, science, or astronomy, we'd love to share our live. And here's from Cliff. A lot of things had to come into play for life to happen here on Earth. We were lucky. Yep. And
quite a lot of.
And for us to get here, there are a lot of extinction events that led to us it being us, not someone or something else. So yes, we're not dinosaurs.
Nope.
So join us again next Friday, June 10th. What are stars and supernovas?
Jeff will be taking that on. I did hear from Sean O'Neill, and we're going back and forth. We should have a date for you soon.
Cool.
Thanks so much, everyone.
Yep.
Have a great week, and we'll talk to you next week. We will watch for your questions again.
Yep.
Good night.
Good night.